All right, this is a brief review on logarithms and specifically for use of logarithms in chemistry and why we're interested in them. The first question is really, what is a logarithm? And a logarithm is a function that's invented to solve a problem that we often run into in science, particularly in chemistry. So let's imagine that you have a number line and you're trying to put on this number line the numbers 1, 10, 100, and 1000. So you start it along and you say, okay, there's 1, say 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10, and then you realize you've already got a problem because 100 is going to end up over here somewhere. And you have no way to put 1000 on this because 1000 would end up somewhere over in Dr. Gadan's office next door to me. So now instead what we do is we say, well, what if we graphed the number of zeros? What if we said that 1 has 0 zeros, 10 has 1 0, 100 has 2 zeros, and 1000 has 3. And this would make for a much easier number line because we would say 1 and we would know that that corresponds to we would say 0 corresponds to 10. We would say 1 corresponds, 0 corresponds to 1, 1 corresponds to 10, 2 to 100, 3 to 1000. And we could do this all day. 4 would be 10,000. And what we need, though, is a function that converts the numbers here into this. So what function would do that? Well, we have a function that does exactly that. It's called a logarithm. So if you take the log, which is short for logarithm, if you take the log of, say, the log base 10 of 10,000, that's the same as taking the log base 10 of 10 to the 4th power, and that would be equal to 4. So the logarithm converts a large number into essentially its exponent. So the numbers and the exponents are closely related here. You can do this with any what's referred to as the base. You can do this with any base. So for example, if you have log base 2 of 16, that's the same as log base 2 of 2 to the 4th power, so that would be equal to 4. A lot of times in science we're going to use something called the natural base, e. This is a number 2.718, blah, 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 that falls out of calculus. I'm not going to go into it in this video where it comes from, but the log base e of, let's say, 2.718 cubed would just be equal to 3. We give a special name to log base e. We call that the natural logarithm, or ln, log natural. And this is going to do the exact same thing. It's going to take numbers that are in the form of e to the 4th power and turn that into 4. All right. So that's what a logarithm is. What do they do for us? Well, logarithms are, as I said, are closely related to exponents. So you know from algebra that if you have a problem like 2 to the 3rd power times 2 to the 4th power, that's equal to the 2 to the 3 plus 4 power, that's 2 to the 7th. All right. Logarithms are basically the exponents. So if you're adding the exponents, that's the same as multiplication. So you can think of this as, imagine we had log of 3. By the way, when we write log without a number down here, we assume it's 10. So log by itself is the same as log base 10. So we had the log of 3 plus the log of 4. That would be equal to the log of 3 times 4, which doesn't make any sense in regular math, but if you do the numbers, we can take the log of 3, that's 0.477, and the log of 4, that's 0.602. If we add those two numbers together, that is 1.079. And if we just take the log of 3 times 4, which is 12, of course, take the log of that, we get 1.079. So here is a useful trick or property of logarithms where the log of a plus the log of b is equal to the log of a times b. All right, and there's a similar one for subtraction. If you had the log of, let's say, 7 minus the log of 3, that's going to be equal to the log of 7 divided by 3. So in other words, log of a minus the log of b is equal to the log of a over b. This last one is important for a question that's come up multiple times in class about the first order kinetics integrated rate law, which is ln of x equals negative kt plus ln of x naught. And the question being, when we graph this, a lot of times we'll see that the log of x versus time, a lot of times we will see that, or every single time we'll see that there is no unit over here. And I've been repeatedly asked, what's the unit? And it turns out there is no unit. It is what we say, unitless. Well, why is that? It's because of this property of logs. So if we move ln of x naught over to the other side, we have ln of x minus ln of x naught equal to negative kt. That's, now, we said earlier that any log, and it doesn't matter if it's log or natural log, minus log of a minus log of b, that's the same as log of a over b. So we're going to do the same thing here. We're going to take this and turn this into log of x over x naught, and that's equal to negative kt. And so the units that would be here, which are usually molarity or atmosphere of these, because they get divided, the units will disappear simply because they're found in this ratio inside the logarithmic expression. And that's why we just simply say that our y-axis is unitless. This is also where the